Griffin, what's the third?
The third hardest magic trick is de-levitating, and that's like getting up there so easy. Everybody is like, you know how you haven't heard of David Copperfield lately? It's because he didn't get the second step of it down. And like the first step is like he's in Vegas and he's like, this time I'm gonna take my act outdoors, right in front of that big Bellagio fountain, baby. Here I go, levitating, up I go. Pretty incredible, huh? What if I made an airplane disappear while I was up here? Nah, just kidding. Anyway, Hey, this is weird. Hey, I've never gone up this far before.
Oh no! Oh god!
Hey,
God!
Hey, does anybody have like a rope or something? Can someone like fly a drone up here and give it? Oh shit!
Yeah. Alright, you can stop it now. Oh, Jesus. Let it down slowly. Alright, yeah. See, this bucket is filled with water, and normally you would think when you turn this upside down, it's going to fill out. But the way that gravity... when you swing something around, it forces everything outwards, just like, you're swinging it outwards. The water is also going to be pushing outwards, and that is why it doesn't fall out of the bucket when Julius swings it around.
Gravity is one reason why water will go that way, down to the earth.
As you can see, the water is dripping. It's also dripping on this plant, which as you can see is pretty small. And also, you're lucky because that spider's pretty small. And you can say thank you to gravity, because gravity impacts cell sizes quite a bit. And if gravity was even slightly less prominent on Earth, spiders would be much bigger.
That's the impact of gravity in terms of weight. You can see this weight has a weight of 51 grams. Together with these one, we have 1,052 grams. Without gravity, the whole thing would look like that, 0. Only with gravity we get a weight.
First off, thank you, Kamikaze Marmot. That's not your name. Just realized that. It's a beautiful marmot, though. Thank you for that. I'm going to talk about how air particles in the air, kind of mess up gravity. This is heavier. As you can see, it falls onto the table quite hard. This falls very softly. It isn't that heavy. In fact, it's very light. And so, the air basically kind of stops it from falling all down super fast, as gravity would like it to.
Fallen impact of gravity.
Yes!
Person is at the North Pole. Not directly at the North Pole. Let's say in Canada, but near the North Pole. There, the person will weigh 65, or we say the person will weigh 65.6 kilograms. The reason why the person could be lighter at the equator is that the Earth is not completely round. So gravity is at the North Pole higher than at the equator, because the North and the South Pole are a little bit closer to the middle point of the Earth, where the most gravity than at the equator, which is a little bit more far away from the equator than North and South Pole.